Safety Codes and Standards, working with Will James. I'd like to introduce Will. He has a few comments he'd like to make. Will is giving us the leadership in the United States Safety Codes and Standards sub-program element of the U.S. hydrogen program. Will?
Thanks, Jay. Before I get started with the presentation, I just want to say thank you to the HIAD Association on putting on such an outstanding conference, and also to the European Commission. It's been a great couple days so far. I look forward to the follow-on day, and also I just wanted to state yesterday from the broad international panel that we had to kick off the preliminary session that it was very good, and it was very good to see how hydrogen is starting to become bigger and head towards deployment and commercialization. And so with that, we present today a presentation on lessons learned we have between the U.S. and the European Commission. So if we take a look, here we go. So if we take a look at how the clean energy sector has grown since 2002, we see that fuel cells compared to the other clean energy areas have more patents than the other clean energy technologies. And if we look at what companies who have been submitting those patents, we see that the patents range from OEMs, portable power, and stationary fuel cell providers. And if you look at the graph over to the right, where it's broken down geographically, we can see where those patents were submitted, what countries those patents were submitted, and they range from the United States, Japan, Korea, and Germany, just to name a few. Sorry, just a slight delay in the slides. And if we look at it from a worldwide commitment from our automobile manufacturers, we see that fuel cells and hydrogen are not just domestic in the U.S., but a global product with more than $1 million worth of investment in research, development, and demonstration. And we see here over on the left-hand side that all the key automobile manufacturers have had commitments to put out fuel cell electric vehicles on the road, ranging from 2015 to 2017. From a market growth and potential side, we see that 30,000 units we've shipped since 2020, which is a 35% increase, a 48% increase in global megawatts shipped. And if you look at some of the analysis that project out to the next 10 to 20 years, we see a $14 to $31 billion investment per year for stationary power, an $11 billion per year for portable power, and an $18 to $97 billion per year for transportation. So with that said, what we are trying to do here as a goal is to have a central point where we can share information and lessons learned related to safety. And one way we've thought about doing that is through the International Partnership for Hydrogen and Fuel Cells in the Economy. And what we propose through the Regulation Codes and Standards Working Group as a small part of a bigger focus is to provide an information portal that will serve as a central point of access for hydrogen safety lessons learned and best practices information. The IPHE will consolidate the information into a single, global, open source, searchable information resource. And as this is one of the kickoffs, we would hopefully have regular IPHE webinars that can serve as another pathway to share information while utilizing resources, knowledge, and experience of IPHE member and partners, which currently the IPHE has approximately 17 member countries. Some of the additional webinar topics that we would like to cover under IPHE, besides safety information sharing, includes H2 resource availability, status of infrastructure deployments, and policy examples to promote hydrogen and fuel cells. And we hopefully will do this twice per year. So the objective of our webinar today is to share the U.S. and European Union information as it pertains to hydrogen safety and best practices, lessons learned, and available databases. So with the way the webinar will be structured is that each country or entity will have 15 minutes to provide formal remarks. We will entertain panel discussion questions at the end for another 20 minutes, and for those in the audience, we will ask for those initially, and the person up front will repeat the question so that it will be recorded into the mic and will be provided later for publication. And keep in mind that the webinar is being recorded, and we will post the webinar with questions and answers approximately 10 days after the conclusion of the webinar, and here I provide the link through our webpage. So one example in which we can use safety information to guide our research and development, and we're currently doing that at DOE, is to look at some of the different incidents that we have, for example, in our H2 incidents database, in which Dr. Steve Weiner will talk about in more detail in a minute. And here's a list of our top 10 areas based on equipment type. If you take a look at the first one, it relates to piping, fittings, and valves. And from that, we can pull in or down to another level and look at the different examples where we see that we have 30 incidents in the database. So hopefully that would help guide our research and development. So before I continue, I want to introduce our speakers for the day. Our first speaker will be Dr. Steve Weiner from Pacific Northwest National Laboratory. Dr. Weiner is a hydrogen safety panel member, which he joined the Washington, D.C. office of P&L in 1993, following an industrial career at Exxon Chemical, Exxon Research and Engineering Company, and Air Products and Chemicals Incorporated, in which he had a variety of R&D, business development, and management positions. Dr. Weiner helped establish the Hydrogen Safety Panel in 2003 and serves as the program's, served as the program Hydrogen Safety Manager supporting the DOE Fuel Cell Technologies Office from 2006 to 2012. He currently serves as a subtask leader for the International Energy Agency's Hydrogen Implementing Agreement Task 31, which is focused on hydrogen safety. Our second speaker will be Dr. Pietro Moretto, who is a nuclear engineer that graduated at the Polytechnico Turin in 1985. He worked at the Nuclear Research Center, KFK, in Karlsruhe, which is now KIT, on materials for the first wall of a fusion reactor, on which he attained a PhD in mechanical engineering. In 1990, he moved to the Joint Research Center of the European Commission to lead the structural and analytical laboratories of the Institute for Advanced Materials. And since 2004, he manages various projects on hydrogen safety and storage at the Institute for Energy and Transport, which is part of the JRC. And with that, I would like to bring Dr. Steve Weiner up to the podium.
Thank you, Will. From wherever you may be participating in this webinar, a welcome to all of you with a good afternoon from Brussels. I want to talk to you today about the Hydrogen Incident Reporting and Lessons Learned database, h2incidents.org. The context for our work was simply stated in a fairly recent report by the U.S. Chemical Safety and Hazard Investigation Board, commonly known as the CSB. They said, near misses and previous incidents provide opportunities for education and improvement only if they are documented, tracked, and communicated to drive safety change. That report contained the following citation. For an example of an online near-miss database, view the Department of Energy's Hydrogen Program website, which facilitates the sharing of lessons learned while working with hydrogen. So today I want to talk to you about one approach, h2incidents.org, the experience and progress, and where we see taking safety knowledge tools such as this one in the future. Huh? Wheel? Oops. I take this premise for our work on hydrogen safety event databases from the Hydrogen Safety Panel, which supports the U.S. Department of Energy program on hydrogen and fuel cell technologies, systems, and applications. They said hydrogen and fuel cell safety event information can serve as a rich and valuable resource if it is systematically collected, analyzed, and used to enhance hydrogen safety knowledge. The sharing of lessons learned from safety events can serve to help prevent similar events from happening in the future. Now that second sentence helps one identify the purpose and user audience for the safety event information being collected. Can it be advanced with the error? What is h2incidents.org? Simply put, it's a database-driven website to facilitate the sharing of lessons learned and other relevant information gained from actual experiences using and working with hydrogen. Its focus is to characterize the incident or near miss and the ensuing lessons learned from the event. And the key principle is that safety event records are voluntarily submitted and posted without attribution. h2incidents.org history. It's most appropriate that this webinar is being presented on location at ICHS 5. At the first ICHS in Pisa in 2005, numerous presentations, discussions, and informal conversations recognized the importance of information sharing regarding safety events and the challenges facing organizations, collaborations, and partnerships in doing so. At that time, in a presentation I gave on the work of the Hydrogen Safety Panel, I noted that any system to receive, process, record, analyze, and act on a safety event requires a great deal of information sharing as openly and thoroughly as possible, some degree of confidentiality and anonymity to prevent the punishment of personnel and encourage a commitment to creating a higher learning value. This principle was based in large measure on the industrial safety event reporting experience of our Hydrogen Safety Panel members. There are now 210 safety event records in the database, of which 3/4 are incidents and the balance are near misses and even non-events. We are very pleased that nearly 20% come from outside the United States, thanks in part to specific international collaborations such as those through the IEA Hydrogen Implementing Agreement, IA HISAFE, and the HIAD team at the JRC. as well as growing interest worldwide in hydrogen and fuel cell technologies and applications. H2incidents.org captures information with emphasis on these parameters: describing the event, its setting and equipment, its characteristics, causes, and contributing factors, all leading to the sharing of the lessons learned and the avoidance and mitigation steps taken. To further emphasize the lessons learned focus, database content is linked to our companion safety knowledge tool, Hydrogen Safety Best Practices, h2bestpractices.org, of which I'll have more to say in a minute or two. Now, I wanted to give you a couple of looks at the database. The setting for safety events, as well as the equipment involved. The setting for a safety event could be a laboratory, could be an oil refinery, or a hydrogen fueling station, et cetera, et cetera. Equipment runs the gamut from vehicles and fueling systems to hydrogen storage equipment to piping, fittings, and valves, et cetera. Please note that there's some double counting of safety events here, particularly for equipment, as we attempt to make sure that we fully capture the various equipment that may have been involved in one way or another in the safety event. The use, as well as within damages and injuries, probable causes, and contributing factors. Key words and phrases may also be entered in an advanced search function that scans safety event titles, descriptions, and lessons learned text. We provide an easy-to-use online form for self-submittal of safety event records, but currently only about 10% of the records we have were actually self-submitted. We encourage this approach and hope more records will come to us in this manner. And we are committed to work with incident owners and other submitters in the manner noted here that will actually result in a posted safety event of value to our database users. I'm pleased that actually increasingly we are getting encouraging responses when we approach incident owners. The fact is that everyone here in Brussels and on the webinar who works with hydrogen and hydrogen-related technologies and systems can be a collaborator in our project, either as a user or a contributor to the database or both. The Lessons Learned Corner feature in h2incidents.org helps focus attention on key safety themes and what has been learned from safety event records that are already in our database. Now, you will note the topics that have been covered in this thematic approach to capturing lessons learned. When a new safety event record is added to the database or any other change or update, et cetera, to any of our safety knowledge tools, we send notices to an international distribution list of interested people. You can be added to that list through contact information provided at the end of this talk. Although I'm not talking much about another safety tool, Hydrogen Safety Best Practices, it's an important context for discussing safety events. To enhance the value of both resources, we provide links for the user as illustrated excuse me, on this slide. For example, in h2incidents.org, we provide links from the Lessons Learned section of many safety event records to specific best practices that should have been used and might have actually prevented the safety event from occurring in the first place. As one example, for a near miss involving the rupture of a small glass vial of an aluminum hydride compound in a glove box, in the lessons learned portion of the record, links are provided both to the lessons learned corner and the best practices on working with reactive metal hydrides. In h2bestpractices.org, Well over 100 links are provided to relevant safety event records that illustrate things that can go wrong if best practices are not followed when working with or around hydrogen. So, for example, there's a section on active ventilation that provides links to 3 incident records in which ventilation problems led to the incident or the near miss. I wanted to provide you with a recent example. Pressure relief device fails at fueling station. To make a specific point about how such resources can be of broader value. In this case, the root causes of the PRD failure, incompatible materials, improper assembly, overhardening of materials, and deficiencies in various quality assurance and quality control procedures were corrected before the fueling station restart. But there's usually something else one can learn from a safety event that to the outsider may not be so apparent, especially if there have been a lot of media reports or vast circulation of secondhand information about the incident. In this case, those learnings deal with timely communications and training of personnel, and that's captured in our safety event record. So where do we go from here regarding safety knowledge tools such as h2incidents.org? Well, for safety knowledge tools such as h2incidents.org and others, it is important to always be looking for ways to share such knowledge more effectively and more efficiently, while always user of that information. So we're particularly proud to have developed what we believe to be the first hydrogen safety related mobile app targeted for authorities having jurisdiction, end users, and a variety of other stakeholders. It's called Hydrogen Tools, focusing on safety knowledge, and it's available now at Apple's App Store. Just type in Hydrogen Tools. Our familiar resources are included, but we have also included what I would characterize as working resources, such as checklists and separation distance calculations. We welcome your feedback on the plan, calculate, and discover design in whatever order you wish to use these tools. I might also add that the app is already showing its value at this conference by enabling the informal discussion of specific incidents and other tools of interest among attendees during coffee breaks and lunch, etc. So let's go to the second half of the premise from the hydrogen safety panel that I started out with. Informed analysis of leaks, fires and explosions, and equipment failure and ignition data derived from these safety events can facilitate the development of risk assessment models and help technical experts identify gaps in applicable codes and standards that can be addressed by a variety of means. Now, certainly, this is beyond the scope and specific intention of h2incidents.org, and certainly not a trivial endeavor. It will require a more concerted effort to capture, share, and analyze safety event information beyond what we've been able to accomplish to date. But I truly believe that it's worthy of our attention. So let me close with a few additional thoughts. Tools like h2incidents.org are very powerful resources. But the challenge is to ensure that the content is current, it's relevant, and valuable to the user. We get lots of feedback and inquiries, and our timely response is important. I think we're making great strides in providing the kind of information and knowledge resources that are valuable to our intended audience. But as the pyramid suggests, data is really the foundation for knowledge. So the challenge is to address what more we can learn from safety events. Our thanks to the staff in the U.S. Department of Energy's Fuel Cell Technologies Office for their financial and program support and that early vision back in 2005 and even earlier regarding the value and importance of such a public database, as well as to all those incident owners and other contributors, users, and stakeholders, and to the ICHS for providing this forum for this webinar. I've included our contact information for those who wish to follow up with both P&L and the Hydrogen Safety Panel. And I've also included a few related references for your information, particularly those that speak to the specific value created through knowledge sharing as well as international collaboration on hydrogen safety. Thank you.
Yes, indeed, I'm Pietro Moretto. I am working for the European Commission, and I'm going to tell you the European part of the story about database, also on behalf of my colleague Daniele Beraldi, who is losing his blood on this database. In order to mark very clearly this geographical jump, probably you have already noticed that we are moving from a very heavy American English to a very light British continental English on this side. Many of the motivation that Steve has given for the American database holds also for the European one. So I'm very thankfully jumping a long introduction on our database because Steve has already introduced the general principle. The European database is called the HIAD. I will spell it now once, is the Hydrogen Incident and Accident Database, but from now on I will call it the HIAD. So the first part of my presentation will be just simply an explanation of how HIAD is functioning, is operating. And the second part will be more on what we have learned from the operation and the usage, and especially what is really necessary to follow the deployment of the hydrogen technologies in general. So let me start with an example that is coming from the typical cycle that we adopt for a standard, classic, already mature technology. For instance, a typical vehicle safety research cycle. You usually start with an already available legislation, safety legislation. Then you review the accidental data. This is to identify problems that the legislation has not looked for, not taken into account. Then you analyze in detail, statistically, the data. You try to simulate in laboratory, again, accidental condition in order to understand more what is the physical, chemical mechanism behind what you are seeing on the street. And on the basis of this, you develop additional improved testing procedure that you feed back in the better legislation. But what is really happening when you are dealing with emerging technology, something that has not even been deployed? You have a very limited amount of accidental data, obviously, because the technology is not yet on the street. And even if you wanted to simulate it in the laboratory, you have very few cars available. Try to buy a hydrogen car and to destroy it in your laboratory. It's not so easy. So the ambition of HIAD is, in fact, that one to fill some information or to collect all the available information for accidental data. In other words, HIAD is supposed to be, is really not supposed to be, it's been designed to be a repository for every accidental event related to hydrogen technology. The wee examples that I have done before was on vehicles, but we are focusing on all the hydrogen technology chains. So there were two major overarching objectives. One was to be an open platform for communication. And the second one was even more ambitious. If you remember, the third box in the previous slides was about performing data using the data for risk assessment approaches. The second overarching objective, as I have to admit, has not been met by our database, but I understood that also the American database is in its infancy from this point of view. Steve probably can correct me later on. The database is fully operational, and it contains 250 events, but that one that are published and with certified with quality are 250. Just a bit of history. It has been developed, the database has been developed in the frame of a European co-funded project of the 6th Framework Program. It was called the HIAD. It was a European Network of Excellence. The time frame was 2004-2009. At the end of the project, the baton has been taken over by the International Association, and there's been further developed and a new analysis modules has been added. All along this period until now, and we hope going on, the database has been maintained and updated and funded by the Joint Research Center. The structure of the HIAD, we have 4 modules. They seem, at least some of them are so obvious that I am ashamed to mention this. We have an entry module, data entry module. We have a data retrieval module. I just mentioned the analysis modules. And we have also some fancy things called the map module. I'm not going to give you detailed operational information on all the modules. I'm not going to tell you anything how to retrieve because it's straightforward. I'm just simply giving you some information on how the data are entered and are treated and an example of analysis. So before speaking about the modules, I want probably the most important thing so you know what the database is containing. Our event as a special descriptor of fields, if you want to speak in terms of a software mentality, that are clustered along a timeline. So you have a sub-event or an event descriptor belonging to the pre-accident conditions. Then we have many information about the nature of the event. Then we have the consequence of it and the post-event actions plus reference. I'm not going to list all of them. I want only to tell you for the comparison freaks among you that if you remember, Steve has given a list of a parameter that is describing the event in the American database. It's simple, it's very clear. The data that you see here are much more. Our ambition was to go very much in detail into the physical, chemical description of the event in order to be able after that to get some hint about the event analysis of it. Obviously, we have also lesson learned, exactly as the American database has. About the data entry module, I just tell you that the user has 2 possibilities, or to send the description of the event to us, and we are going to do it for him. And this is very much an approach like the tax office of the Netherlands, that they cannot do it, that seems nicer, but they're trying to do it as easy as possible. Alternatively, the user or the interested person can become an event provider by registering in a different way, and the event provider can access directly all the fields for the input. Not all the data, the fields that I shown before are compulsory, only very small amount, and all the data can be put anonymously inside the database. This doesn't prohibit someone that is very proud of his accident to write all the possible details of a street and names about it. But this is a very case, we have never seen such a case until now. Now what happened to our data once that you have put you enter the field? It's not immediately directly published, available. The data is submitted from the HIAD administration to a quality assurance expert group. They're analyzing, they're looking at some criteria of quality like appearance and consistency. After that, a kind of data qualification stamp is given to the data. The administration then is marking the data for publication. Only at this moment, the database reader can see this document, this data. This is an example of the website entrance page for the data analysis modules, but I would not like to go in detail in all the possibility of the statistical analysis that you can perform, but I wanted to give you an example. This is an example of, we have selected the total number of involved people as the major parameter for the analysis, and we wanted to see the distribution of this parameter according to the causes of the accident. So in this case we have 4 different accident cause: explosion, fire, in this case we are meaning classical fire, or fire which is hydrogen fire as a third cause, and then the release of hydrogen. This is one of the many possibilities. For the people who are really going beyond the first level, I already can imagine the first question: what does it mean? Which is the definition of a number of involved people? In this case, is all the people that could be injured or even caused to move from the place, evacuated. All the people that have been affected by the accident. This is an example of the maps modules, is giving you a geographical distribution of the event. This is only possible only when the event provider has provided indication of the place where it happened. This is not a compulsory information. So not all data can be geographically distributed and placed. Now, I would like to finish this. I terminated the part of, I tried to answer the question how the database is functioning. Now I wanted to give you some information from what we have learned at GRC, from its functioning and operation, and from the interface that we have got with the event provider. So one thing must be said. It is clear, everyone is agreeing that the tool is essential. It's essential for structural dissemination information as a repository across time. And it's also going to be very useful for an optimization of the safety aspect of the emerging technology. And we expect that this is going to become more and more important as a tool the more the hydrogen technology is becoming mature, is deployed. But to keep the tool up to date with the development, there are many things that still has to take place. We have identified some recommendations, some requirements. One of these is almost obvious. No, it's obvious, not almost. We need someone who is committed to provide information, to provide the event and the description. It's obvious that the first responder should not be made responsible for this. They have a completely different things in their mind. We have to speak with the licensing body, with the people that are examining the accident after that and are responsible for the final reporting. So, and we need also a distributed European-wide network of data providers. The second requirement has to do with the quality of the event reported. Every one of us is very busy. We are trying to input, if not force it in a different way, to input the minimum amount, quantity of data that we are having there. Additional source of information like local journals do not provide the required resolution and quality. So there must be an access to the final analysis of the event. It doesn't matter where it is. To this respect, the example that Steve has done before of one of the most recent accidents, the Emeryville accident report, is a beautiful example. It contains everything what is necessary for an analysis. It is already available there almost publicly. So what we have done after that, we have identified this requirement as essential. We have done already something. Since 2013, which is now, we have an agreement with the Fuel Cell and Hydrogen Joint Undertaking, which is, for some of you who doesn't know, is the financing body in Europe for the R&D on hydrogen technologies. Especially the demo project there are now committed to report to HIAD or to JRC all the events that occurred during the performance of the project. And in fact, the recommendations that I mentioned before are coming already from some critics that we have received from them. But what we are still missing is a commitment from private commercial installations. And we have done also some bit of communication across the ocean, Atlantic in this case, so that the two databases are speaking to each other, not quantitatively, but we have already started to exchange a very limited amount of data between the two databases. There are still things to do, and this is my last slide. We have to improve user usefulness. We have end user usefulness. We have to improve the communication. We have to also help the event provider to have an interface that is easy for inputting data. It's not written in my slide. I will tell you on voice. Unfortunately, what I'm saying is going to be recorded. The designer of this database were a group, a team of many different components of the engineering spectrum. A big component was quantitative risk analysis experts. And we know that these people are not the best in communication. So this is reflected in the structure of the database, which is not helping the normal, I would even say neurotypical people to understand how the database is functioning. So we have to make an effort to improve not the structure of the database, but the interface with the external world. If we are getting funded, we will do it in the next 2 years. The second thing is that, as Steve has said, it's extremely important to have a team of people that are interfacing with the event provider, grabbing for details, increasing the quality and the resolution of the data provided. And it would be nice to have a kind of safety team, safety group, always available and broad enough that we can count on it every moment of the day and every moment of the month of the year. So now I don't have any solution. Yesterday evening, the last brilliant thing that I could think before closing the drafting of this presentation was that there could be some joint force across Atlantic on this. My last slide is just simply reference to published work that you can find on the net. Thank you very much.
I'd like to take questions or comments from the audience, please. The live audience, and then we will go to the web. Okay, well, while you folks are pondering your question of choice, we do have two which were posted on the web. Will?
Yes. So the question for the HIAD folks, Pietro.
No, we have it.
He's got it.
The slide in which you listed the years of the most distance, is there any type of scenario or reason that accounts for the 2 or 3 years that has the most distance?
No, you have to repeat. You repeat. No, you repeat, because I didn't understand.
So would you repeat it once more, please?
So there was a slide in which you listed number of events by year, and there were several years which had a significant amount of incidents. Was there anything that you could relate to? Was there a scenario or a certain event that caused that many events to happen in those 3 years?
I repeat again the question because the audience in the room probably has not heard. The question coming from the web is related to the slides that I've shown as an example of data analysis. And there is a kind of granularity in the data. And in some year there is an enormous higher or very big number of people that have been involved in the event, in some other not. So obviously I don't remember all the exactly type of event that was happening in different years. but in 2 or 3 cases, I remember that I remember at least 2 that have increased, that are bringing up the number of people involved at a pretty high. One is an event in Pakistan in a factory producing butter. There's been a very low injury, but a high number of evacuated people. And another event with even a higher number of involved people was an accident in a chemical factory. They were producing a kind of acid. I don't remember anymore which one. There's been only 1 death, few injured in the factory, but there was a nearby hospital, and they had to evacuate all of the people of the hospital. So it's the database allow to jump from this statistical analysis directly back to the individual events, and then you can get a grip of what is really happening behind the data. But I cannot demonstrate it now because we are not online.
So one more question while you're here. Is there any way to use the database to drive your research and development within the JRC or within any of the European projects?
Our original ambition, probably I have to repeat the question before, so I'm trying to read it. Well, I do not know where to read, but so is this one, okay. Is this a reason of scenario that accounts for your highest, no, this is not this one, this was a previous one. Okay, I repeat what I understood from Will. If the database has been already used to drive research, JRC, or in general in Europe. So, related to our original double overarching objectives, the repository of database, of a central repository for events and also of lesson learned has been regularly used. The database is regularly consulted about this, as well as the American sister of it. The second overarching objective was to have a base, a statistical base to start risk assessment or even quantitative risk assessment. Well, this is not yet achieved. The number of data are not enough. You would say 250 data are a lot, but if you think that are related to the whole hydrogen technology chains, you come down to very few events for the individual scenario, accidental scenario. So this is not yet enough for drawing statistically based quantitative analysis for this.
So the next question is for Steve. Can you explain how NREL and their composite data product, if that's being incorporated at all, or the data that NREL is using is being incorporated into the database?
It's not being incorporated into the database. That data is received and analyzed by NREL in a confidential manner, and the products that are outputted and their outputs from their secure data center are in the form of these composite data products. Now, those composite data products provide a lot of useful information about where incidents are occurring, et cetera, but the information is not in the right format for incorporation into specific safety event records in our database.
So the next question is also for Steve, and the reason I understand this one is being from the U.S. Is there a form or checklist that could serve as a cheat sheet of sorts to help ensure the right questions get asked if you don't have the properly trained person on the scene?
A checklist for an investigation of a?
No, just a generic checklist.
Well, we have checklists. Okay, the question is, are there checklists available for when someone arrives on the scene of an incident. Did I capture the question correctly? And I guess the simple answer is no. But the use of checklists and the use of guidance information in terms of planning and conducting work is an important and integral part of not only our best practices safety knowledge tool, but the work of our hydrogen safety panel.
So are there more from the web? Okay. Thomas, you have a question?
Yeah. Well, maybe in a similar direction, the question would be, who takes care for quality assurance of new data? This means there is actually required a continuous review of new data. At least at the HIAD exercise, we had first initiation of such a quality assurance. Effectively, I guess such a board as the hydrogen safety panel would be predefined or ideal platforms to do this quality assurance.
I don't need to repeat the question, do I? Okay, absolutely. I absolutely agree. We do quality assurance in a variety of ways. Initially with the database, we actually took safety events early on from other databases, okay? And those records go back many, many years. If you do a search on our database, you'll see incidents from way back. But we all realize that knowledge is continually being gained regarding safety and safe conduct of operations. So as incidents were being submitted, we were responsible for the quality assurance. We, meaning P&L, was responsible for the quality assurance. And we would use either technical experts within our own organization. We'd use hydrogen safety panel members. We utilize people from other national laboratories. For example, I mentioned the incident example with metal hydrides, okay? And so I think simply put, we've done quality assurance in a variety of ways. Sometimes we actually write the incident for the incident owner as we have the information to relieve them of the burden, but then have an exchange and make sure that it's not posted until they sign off on it. And when we get queries from people, from users of the database about information, we go back, or the need for information, we go back to the incident owner and make modifications to it. So in short, our panel serves a key role in this and is an important aspect.
Okay, we have one more from the web.
May I say?
Sure, go ahead.
Just a bit to answer, to complete what Steve is saying. It must be clear that the quality assurance panel is not just simply someone sitting behind the screen and judging yes, no. What Steve has said is an important component of the whole process, interacting with the event owner or provider, trying to grab what we need. So this is extremely important. So it takes some time for this.
So Thomas, you still have a comment?
Yeah, maybe a historical question. You know that both databases were born in a similar time, and we had very early discussions about common activity there. Despite these trials, two parallel developments were there with let's say, a slightly different objective on both sides. But how do you judge upon the, let's say, goal or maybe the idea, which is maybe still alive, to merge these two activities, to bring together both concepts? Is there an opportunity? Is there some let's say, reasonable meaning behind it?
The question is, we have two different databases. I think you can appreciate some of the differences between the two databases. But I think, they're still, whether it's merging or actually, I think there's some other very intriguing possibilities for collaboration between the two databases, particularly from the point of view of what we actually learn from incidents, what we learn and what action we take from incidents. We have a certain set of users. I mean, you'd be fascinated by who some of our users are. We have university undergraduate researchers who look at the database and then have to present to their class a presentation on what does management of change mean in a laboratory. Something we would not have envisioned before we started. So we get a lot of feedback on that sense. But if we think of the bigger picture, and I think out of what I've heard and what I've presented and the discussion at this meeting, that there are some intriguing possibilities for collaboration between the two databases that might be very valuable for the benefit of all of what we're all trying to achieve.
Okay, so I see no more questions. We do have one more question here, please.
Just as we are talking about cooperation, I think we should look out in the world and find if there are other databases of that kind, maybe from natural gas or from the chemical industry, actually operated by insurance companies, and which already have an interest in knowing about what has been caused root for an incident. Is there any plan of linking these information together, or maybe because there could be a possibility of finding out similarities in technologies and maybe how to avoid hydrogen accidents in the future?
Go ahead.
First of all, I would like to remind that the HIAD has been developed with substantial help, not help, but really part of the designing team was an insurance company. So the structure of HIAD is allowing already this. And in fact, the data analysis modules has been particularly developed by this insurance company, which after that later withdrew and is not directly more interested in the database. So there could be already the structure of database is already helping in going in the direction that you're suggesting. The big hurdle that we have never been able to come over is that the databases that are containing really a lot of data, not on hydrogen technology, but on similar technologies like compressed gas technology, are commercial database, usually led by non-governmental organization. And there are so many different legal and financing and even speaking the same language difficulty that with our limited manpower we have never made a step in that direction, a positive one.
Steve, go ahead. Can I make a quick comment? Yes, that's an interesting thought. And I believe that there are potential opportunities for interaction and where we could collaborate in terms of without compromising confidentiality. Okay, but you have to also remember that this is a public database. And so, for example, there's an organization called the Center for Chemical Process Safety, run through the American Institute of Chemical Engineers. They have a database. Okay. But it's only accessed through people who are members of the center, all of the partners who are members of the center. The way we act on what are coming out of safety incidents and what are issues that have to be addressed, forget about whether we're talking about specific incidents, is through our hydrogen safety panel. So we have members who actually have access to incidents and learnings and are bringing their subject matter expertise to bear on our addressing the issues. So we are achieving in some way and lessons learned from incidents and learnings that are of a confidential nature, which ultimately in addressing needs will sort of help lift the boat for everybody to help enable hydrogen fuel cell technologies.
Okay. Well, I want to thank you very much, Steve, Pietro. Thank you for a good discussion. And of course, I want to thank our folks back in Colorado and USDOE who did the mechanics on our webinar, which you didn't know this, but we had on the order of 100 people also listening in. So this was very, very good. Thank you, folks.